continue. Does anyone raise a hand? Okay, no hands raised so far. Oh, I think they record them, yes. So from the diagram, the probability that event B will occur, given that event A has occurred, as we know. So from the diagram, the probability that event B will occur, given that event A has already occurred, is probability of B, given that A has occurred, is forward-looking probability in the sense that event A occurred before event B. So the person went to school before the person started learning. So that is the understanding from the probability of B, given that A has already occurred. So suppose instead that we are asked to find the backward-looking probability that event A occurred, given that event B has already occurred. So this is what we mean, that find the probability that the person will go to school, given that the person has already learned. That is the backward looking. So that's why people say it's the reverse. Instead of going to school to learn, this time we can be asked to find the probability that someone will learn, sorry, the probability that someone will go to school, given that the person has already learned. And what helps us to solve that issue is the Bayes theory. So the Bayes theorem gives us a way to find this probability by using the formula. So this is the formula. The probability of A, given that B has already occurred, is equal to, the numerator will be probability of A times the probability of B, given that A has already occurred. Let's kindly pay attention of the arrangement here. So over here is what we already know, the forward-looking one. So the probability of A, if A, given that B has occurred, is what you are looking for, that means that you write probability of A times the probability of B, given that A has already occurred, then divided by the probability of A, given that times probability of B, given that A has already occurred, plus the probability of A complement times the probability of B, given that A has already occurred. Sorry, the probability of A complement times probability of B, given that A complement has already occurred. So if we are supposed to situate it in our example, where our example event A means that the person goes to school. Go to school. While the B is the event that the person learns. Person learns. I'll get the writing part. I don't like these handwritings. So it's the probability of going to school, given that the person has learned here, is equal to probability of going to school times probability of learning, given that the person has gone to school. Or on probability of A, which is the probability of going to school, times the probability of learning, given that going to school has already occurred, times, sorry, plus the probability of not going to school, plus the probability times the probability of learning, given that the person did not go to school. Mind you, all these ones would be given. If they are not given in the question, that means they are embedded in it. So you will maneuver our ways to find them. Then we effectively use this formula, probability of A, given that B has already occurred. So we may want to pay attention to the formula, write it down so that we will be able to apply it or you would understand it when we start applying it. So I will employ everyone. Please kindly write it down. Kindly write the formula down. Do we have it down? So by extension, we can extend it. We can extend the base theorem to several mutually exclusive events, just as we did for the conditional probability. So probability of A of i's occurring, given that B has already occurred. So the I can be as many as we want. So let's pay attention here. Because the A comes before the B, we first find the probability of A times the probability of B, given that A has already occurred. Then we have the A1, probability of A1 times probability of B, given that A1 has already occurred, plus the probability of A2 times the probability of B, given that A2 has already occurred, up to. This I hope we understand. The reason why I wanted to pay attention to is, let's say another
So
instance.
kindly go back one step.
Is it here?
Yeah, that's right. Okay.
Do you have a question here, please?
Oh, I just want to write the formula.
Okay.
We can continue now. Thank you.
So let's pay attention to the formula. So I want us to write the formula. Maybe probability of, let's visit our good friends X. Probability of X, given that Y has already occurred. Oh, what's happening? Let me use something first. Let's see if we can write the formula for probability of X, given that Y has already occurred. Let's see. I want everyone, each one of us to write based on the formula that we have written. I want us to write it. Let me give you some few minutes because the questions we are going to give you differentiated ones. So the first thing is if we're able to write this formula. So I want to give you some 3 minutes. Look at the ones that you've written down, compare to this one, and then you write it. So let's go. I'm giving you that 3 minutes to do that. Okay, so how many of us have found it? Anyone to help us so that we can write it for everyone to. Kwakubwama.
Hello, sir.
Yes,
The
please.
probability of x given that y has already occurred is equal to probability of x multiplied by probability of y given that s has occurred, all over probability of s times probability of y given that
Oh,
s has occurred plus prob-
oh, please let's mute ourselves. So Kwakubwama is on the floor. So if you also want to talk, Eric, Eric, kindly mute yourself. Good. Kwaku, please kindly come again. Let's go.
I said probability of x given that y had already occurred is equal to probability of s times probability of y given that s has occurred, all over probability of x times probability of y given that x has already occurred plus probability of x not occurring times probability of y given that x has not occurred.
Okay, that's great. Let's see that up. Samuel, you can kindly come in. Do you have the same?
Yes, sir. Sir, I had the same
What
answer.
is
Yeah, I had the same answer.
okay? You have the same answer. So this is what I think you ran faster than my hands were moving. That's great. Now the probability of S not occurring. Sorry, the probability of S not occurring. Sorry. Did you get this? Probability of Come on, did you get something like this? Together with Kakubwama.
Yes, sir.
Okay, some of what says it had the same thing. Oh, okay, that's great. Now we continue. So I can effectively say that the formula, we are masters of it. How to code the formula, we are masters of it. So we can continue. So now we want to, you remember, we had a question regarding the sales representatives, which we go back. Let's go back to, I think we all have the slides now. Let's go to the slides, page 23. So I'll go back to the slides, page 23. I think this one. So let's read and we jot some things down. Then we'll come back to our page we are currently on. So a company has 300. No, let me have someone read for us. And please, anyone to help us with the reading?
Dorcas.
Hills on hill. When I saw you, I thought you were coming to talk. Yes, Lucas, read for us. I think the class has voted for you.
Okay. A company has 300 sales representatives. During the past year, 48 of the sales representatives earned a bonus by selling over their quota. At the beginning of the sales year, the company offered a special training seminar, which was attended by 138 of the sales representatives. 27 of the sales representatives who earned a bonus had attended the training seminar. A. What is the probability that a person who attended the seminar earned a bonus? B. If a sales representative is selected at random, what is the probability that the person attended the seminar and earned a bonus?
So now let's move on to our question. Let's pay attention to this one. Let's pay attention to this one. So now we are rather using this question. What is the probability that a person who earned a bonus had attended the training seminar? So now we have changed the question. What's the probability that the person who earned a bonus had attended the training seminar? So we are looking at the reverse. And based on the number of sales representatives who earned a bonus, would you say that the training was effective? Say that the training was effective. So let's look at it. Okay, solution. Let's get the tree diagram set up. So I think the other time we explained this tree diagram. This tree diagram. Okay, so we have 300 sales representatives, and then we have 48 who earn the bonus by selling over their quota. So we have two events here. The event here, we have one, those who attended the seminar, and the other event is those who received bonuses. So in total, there are supposed to be 48 who received bonuses. And then 138 of the sales representatives out of the 300 attended the seminar. So that sets up the P of A equal to 138 on 300. If 138 out of the 300 attended, that means that 162 did not attend. That sets up this probability of A not occurring. This I hope we understand. So we construct or we set up the first part. Now on the second part, we have it that 27 of the sales representatives who earned a bonus had attended the training seminar. So B is the probability of earning a bonus. So probability of earning a bonus, given that you have attended the seminar, now is 27 out of 138. Now the complement which we had, this is gotten from 1 minus the probability that B will occur, given that A has already occurred. So we essentially just subtract this from 1, and we had the 111 on 138. So you may want to jot this formula down, really important. So B and B complement, given that A has already occurred. When you sum, you should get 1. So if you have 1 and you don't have the other, you just subtract the other from 1 and you get it. Now we have the probability of A not occurring, which we are set up as this. So we can have the probability from the question. 48 people received the bonus, and the question says that 27 of them had attended the seminar. That means that 21 of them did not attend the seminar. So we have 21 of those who received the bonus not attending the seminar. That gives us 21 on 162. Then we can find its complement by subtracting this from 1. If we subtract from 1, we get the 141 on 162. So this is gotten from this by subtracting this from 1. That is where you get this probability. This, I hope we get this page.
Please take the second part again. The A complement, probability of A complement.
So the probability of A complement is 162 on 300. I think that's one we understand. Now when we go to the second line, it says that 48 of the sales representatives earned the bonus by selling over their quota. When you go to the fifth line said 27 of the sales representatives who earned the bonus had attended the training seminar. That tried to tell us that 21 of them did not attend the seminar. See, so this represents those who did not attend the seminar, but they earned a bonus. So this is the probability of those who earned a bonus but did not attend the seminar. So probability of B occurring given that A did not occur. That is what we have as 21 on 162. And the probability of not earning a bonus given that A had not occurred, that gives us the 141 on 162. Simply gotten by subtracting this. If you subtract this from one whole number, you get 141 on 162. So that subtraction, I want to do it here. You have it 1 minus 21 on 162. And obviously, you get the 141 because when you set up the LCM, you get 162 minus 21, and that gives you 141. 141 on 162. But I hope we get it. So we set up the tree diagram. Then we apply the formula. Okay, so we applied the formula. So I think when we look at the previous one, now this is the formula. We have the formula here. So as we're able to write it, we go to the tree diagram. So everyone, let's get the formula down as the question is demanding us to find the probability of attending the seminar, given that the person has already earned a bonus. The probability of attending, sorry, the probability that a person who earned a bonus had attended the seminar. So the probability that the person who earned the bonus had attended the seminar. That means the P of A, given that the person earned the bonus. Sorry, attended. P of A, given that B had already occurred. So to set that one up, we now barely substitute what we use the tree diagram to do. So we go on with the substitution. So when we go on with the substitution, P of A from the tree diagram is this. P of B and the bonus given that you have attended the seminar is here. And P of A is here. P of B given that A has already occurred here. And that goes on and on and on and on. So we conclude that the answer is 0.583. Please, I hope we understand because these are substitutions. After the substitution, we continue with the mathematics. which the calculator can help us with, and we conclude that way. Please, can we continue? So we continue. I think I'm not hearing from you. Silent consent. Is giving their consent to the continuation. We continue to find the probability that a person had not attended the training seminar, given that the person earned the bonus. Because why are we finding this? The B says that based on the number of sales representatives who earned a bonus, would you say that the training was effective? We want to check the effectiveness of the training. So to do that, you have to juxtapose those who earned the bonus, given that we have to find the probability that the person did not attend the seminar, but the person earned the bonus. So the probability that the person had not attended the training seminar, given that the person had earned the bonus. And to do that, you merely just subtract the probability of attending the seminar, given that you have earned the bonus from that, and you get the 0.437. So to check it, you can conclude that the seminar, because this is 0.437, and those who attended the seminar and earned the bonus was 0.563, which is relatively higher than the 0.437. We can conclude that the training seminar did seem to increase a person's probability of earning a bonus. This is because those who had attended the seminar and earned the bonus had their probability higher than that of those who had not attended the seminar, given that the person earned a bonus. Please, I hope we get it. Please, I hope we get it. Oh, they can hear me.
Yes, yes, sir.
Let's look at the second question. A manufacturer orders certain parts from 3 different suppliers. From the past record, it is found that the 3 suppliers have the following percentages of defective parts. So defective parts, we have 6%, 5%, 4%. That's for supplier 1. Supplier 1 has defective part 3%. That means the good percent will be 97%. Supplier 2 has defective part 5%. That means the good percent will be 95%. While supplier 3 has defective part 4%. That means the good part will be 96%. Please, I hope you get it. Oh, please, whoever has unmuted, I will leave with you. Please, can you mute yourself? Martin, can you mute yourself? Martin, you are laughing. Martin, please, can you mute yourself? Your voice is disturbing the class. Thank you, Martin. Thank you for agreeing to that. The current inventory of parts contains 5,000 units from supplier 1, 3,500 units from supplier 2, and 2,000 units from supplier 3. So now, if a part is chosen from the inventory at random, what is the probability that it is effective? I would want everyone to pay attention to this one. Let's write the important information out. I know you have the slides. I know the solution is on the next page, but please don't quickly rush the solution. Let's go one after the other so that we will solve it together in order for everyone to understand it. So please, let's write the important information from it. The important information is the first table here, effective parts, good parts, and the tables. After that, we write the inventory part from each of the suppliers. Please, let's do that so that we will solve it. I'm going to change the board to a white one, and we solve it so that each one of us will understand the calculations that is done on the next page. So please let's write the important part down. Let me give you just a minute to do that so that we can look at it. Let's be quick about it. Please, have you written it? Have you written it? Oh, I hope my network is good. Let me see.
Yes, sir. We
Please,
have. We have.
I want to hear the voice because I'm not on this window. I will be at the presentation because I want to give you a whiteboard. So please,
Oh, okay.
and I haven't extended my screen. So I'm currently at only one screen. So when I ask, I will keep that you kindly bear with me so that you give me a response.
Okay, sir.
Okay, please. So we are ready. Let's move on to the high screen. So from the important ones listed out, we first to help us with the tree diagram, we need to get the probabilities of each of the suppliers having their oh, what's happening? Can you give me a minute? I think it's okay now. So probability of we getting or having our parts from supplier one. We report that P of S1. And from the question says that supplier one from the inventory, he had 5,000 of the parts being supplied to us. So we have 5,000, 5,000, all on the total number of parts. And we know the total number of parts to be, if you add them, 5,000 plus 3,500 plus 2,000, that gives 10,000. That gives 10,500. And that can be written in its simplest form as n out of 21. So that gives that of supplier one. And that you find the probability of getting the parts from supplier two. The probability of getting the part from supplier 2, we'll have it as 3,500. So all this information, marks are located for being able to get an information like this from the question. 10,500. Ish. That's how they are appearing. They're not really appearing nice. I really have to get the writing pen. That gives us 7 on 21. For 0, then 5 goes into 35 as 7, and 5 goes into 37 and 105, giving you 21. And you have Q.
Hello, sir.
Yes, please.
Please, can we also write it as 1 on 3?
Yes, please. You can write as 1 on 3. The
Thank
reason
you.
is we wanted to leave everything because when we get to the denominator part, you have the 21, 21 for simplification of addition and not
Oh,
really have to now find the LCM once again. That's why
okay.
we decided
Okay.
or decided to leave it in the same denominator throughout.
As like fractions.
Yes, as like fractions.
Okay.
So here you have it as 4
4 on 21.
or 21. But I hope we get it. So the first thing to do is to get the probabilities as we've had here. So that is on the next slide to get the probabilities. So having had the probabilities, you now set up the tree diagram. Why do you do that? The tree diagram helps you to visualize it so that you can just pick the various ones that you need in your formula. That's why it's essential to draw the tree diagram. So because I want to think that not every one of us can directly or write the other probabilities needed from our mind, I will teach with the tree diagram. And I wish that we follow that as well. So having had these probabilities, we will look at the tree diagram. So I'll now write this right. So now let's look at the probabilities for supplier 1. For supplier 1. So for supplier 1, let's look at the cases for supplier 1. So for supplier 1, as we are seeing, the supplier 1, his probability is 10 on 21. So if we turn our focus on supplier 1 can supply us with good parts and then supply us with defective parts. They can supply us with good parts and then will supply us with defective parts. But because the question focus on defective parts, we will look at defective parts. So we will make D represent the probability of defective parts. So we are looking at probability of receiving a defective part provided by supplier 1. So given that it is coming from supplier 1. And the question says that the percentage probabilities are percentages. So the percentage is 0.03, that's 3%. The 3% represent the probability. 0.03. And the probability of supplier 1, the opposite of defective is good. This time we are not writing G, but rather D complement so that we can get it. Supplier 1 supplying us with that. So having a good part given that it is coming from supplier 1 is 0.97. I hope we understand that of supplier 1.
Yes, please.
Yes, sir.
Okay, that's great. So we move on to that for supplier 2. Let me uh, so the probabilities for supplier 2. With supplier 3, you will do it at your end. Supplier 2, we have the probability as 7,
7
I
on
think
20.
7 on 21. Supplier 2 can also give us something good or something defective. Our probability of getting something defective, provided it's coming from supplier 2. And that probability is 0.05. And then the probability of getting something good coming from supplier 2 from the question is 95%. That is 0.95. Now I will want everyone to set up that for supplier 3. Let's do that on supplier 3. Let's do that for supplier 3. Have we done it?
Yes, please.
Did you get something
Yes,
like this?
please. Yes, sir.
Yes,
Yes,
please.
sir. Yes, sir.
Yes, sir.
So there is something that I left out which we need to pay attention. The base theory. Let me go back to where I first introduced the base theory. So let me go to where we first introduced the base theory. So here, for instance, let me go back again. Here, the denominator here, this denominator, the sum of this denominator should give you probability of p. So let me erase some things and now tell you how the Bayes theorem is expanded to this form. So in its simplest form, the Bayes theorem was giving us, it just came to mind, I thought I had said it. So probability of A, even that B has already occurred, in its simplest form is equal to, please, we would want to also write this formula down because it's really important. Probability of A times probability of B, given that A has already occurred. Now times the denominator here is the probability of B occurring. And to get the probability that B occurs is this expanded this form. So all of these, the sum here, probability of A given that times probability of B given that A has already occurred, plus its complement is sum up to probability of B occurring. This I hope you understand. So please let's
Yes,
jot
sir.
this one down. So if you want to get probability of B occurring, you look at probability of A times the probability of B occurring given that A has already occurred, plus the probability of A complement times probability of B occurring given that A complement has already occurred. So in essence, if we are supposed to expand it here, the whole of the denominator here is equal to the probability of B. So when you use that formula that we shown here, the whole of this denominator will give us probability of Y, which so let's get back to our question. Our question here is telling us that if a part is chosen from the inventory at random, what's the probability that it is defective? So essentially, we are looking at probability that it is what? Defective. That is P of D. P of D. That is what we are looking for. And here it says that if a part is chosen at random from the inventory is found defective, what is the probability that it came from supplier what? Supplier one. So here we want P of S1 given that it is what? Defective. What has occurred first? What has occurred first is that it is defective. Now we want to find the probability that it is coming from supplier one. So this is probability of S1 given that it is defective. So how do we get probability of defective? Probability of defective. And it's gotten from here. So the denominators, this times this times that, and this times this will give us probability of defective. So you look at probability of getting S, then multiply by this, then probability of this multiply by this. I think this can be gotten from the conditional probability, the formula for conditional probability. If we remember, if we remember what we taught or what we learned on which day did we end? What we learned the first day we met, you can get that formula there.
Yeah.
The probability of S3 and this 2, you can get that formula there. So when we find the product of this and that plus the product of this and this plus the product of this and this, you can get the probability of defective. That's what we do here. Probability of getting the from supplier one times the probability of it being defective, given that supplier one did it, and that is what we have here. So we merely substitute. That substitution leads us to this part, and when we're able to simplify it, we get the 0.039. So therefore, the manufacturer can expect approximately 4 parts out of every 100 of the defective. The interpretation is if we run it, we get the 0.04. And 0.04 can effectively be written as 4 on 100. That means that out of every 100, because we are having so many parts in percentage wise, it means that out of every 100, you are going to get 4 of them being defective. That is the expectation that the supplier should have after our calculations. Please, do we get the probability of choosing a defective part?
Yes, sir.
Does anyone have a question?
Yes, sir.
Yes. Let's look at
Ah,
your question.
Sir, I thought we were going to add only the probability of defective as the supplier one. That part 0.03 plus the 0.05 and 0.04. But not knowing you multiply by their respective probability of supplier one and the rest.
Yes, you ought to multiply by the probability of those suppliers. This is because if you get probability of it being defective coming from supplier one so is also coming with his number. Please, I hope you understand. His number of parts. So we need to find out how many of them is coming from supplier one. That is why you multiply by the P of S1. And then you find out how many of them is coming from supplier 2. That's why you multiply by P of S2. Please, I hope you understand. That is why the multiplication is
Yes,
there.
please.
Okay. So the second question now tells us to, using the Bayes theorem, we're supposed to find that it is found to be defective. What is the probability that it came from supplier 1? So P of S1, given that D has occurred. So to do that, we go by the formula P of S1, given that D has occurred. Here you list all the probabilities up. So here, once you have found the supplier ones, sorry, P of defective, you can simply put write P of D. But you can use the expanded, this is the expanded Bayes theorem. So here we went with the expanded Bayes theorem, and it merely gives you this, and you arrive at 0.0376. We have a really low probability that it is found to be defective, given that, sorry, it is coming from supplier 1, given that it is defective. The probability is 0.037. So all these, I will skip these ones because they are merely calculations. Please, do you have a question here? Let's continue. I think there is an issue with the calculation there. Please kindly verify if it is 0.037. I'm not seeing to be 0.037. It should be bigger than that. Let's verify the calculations so that we will make changes to our slides. Yes, please. Have we verified? Let's verify that. Let's see what we had because I'm
Right.
disputing it.
0.36.
It's 0.36 instead there.
Yes, please.
Let's see. Let's see from others. It's 0.36. Man, what do you think? Because you have unmuted for a while. Jacob also said 0.36. Okay, so let me make changes.
0.37.
Hello, sir.
Yes.
Yeah, it's 0.359.
0.359. What in Samuel? You are laughing. You asked
It's the
Dr.
same as
Dixie.
0.36.
Okay, Eric, you are laughing.
So
Hey,
in three decimal places.
okay, let's leave it in three decimal places.
So 0.359.
0.359. 0.359. Good, 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 good. So let me make changes because when I saw it, I should get something bigger. Let me effect the change here. We said we should get 0.35. Is it 35? 359.
359.
Okay, great. Let me save it. Okay. So you make changes to it. You make changes at your end. Ideally, I've made them. I should have sent the PDF to you, not the PowerPoint. But once you have the PowerPoint, it's okay. Please don't make changes to it too, because any changes you make will be seen as if it's coming from our coordinator. So, and once you have downloaded it, I don't have authority over the slides any longer. But please, don't sit somewhere and make changes to the slides and we'll attribute it to our course coordinator. Otherwise, it's not, it goes against the integrity, academic integrity and all. So let's go do this change. So I'll send the rectified one. Let me see if I can delete it. Right. So people have it. So it won't really amount to anything. But I still have to delete it so that I can still have the authority over something small. Okay, let me delete it fast. I've deleted it. So let's look at the second one. A man is known to speak the truth 2 out of 3 times. He throws a die and reports that the number obtained is a 4. And we are supposed to find the probability that um, the number obtained is actually a 4. So let's write the important things out of it. Then we will solve it. With the trial, you have it as exercise, which I would expect solutions to our employer on you to please you solve it, you put it on the page, whilst I mark it for you. If you are to send it to my DM, 100 people DM, you increase the storage size of mine. Not the storage size, you increase the things I've saved on my phone. So I will plead with you. I won't take it as emails, but just put it on the page. I look at it. I just look at it. I wish that I have. Yes, please.
The deadline for the assignment.
I'm not really an assignment, it's a trial work. So that this not this one is a trial work. I think it has its solution even in your slides. Okay. have to make changes to so many things here. So let's look at the exercise one. A man is known to speak the truth 2 out of 3 times. He throws a die and reports that the number obtained is a 4. Find the probability that the number obtained is actually a 4. Let's quickly get the important information from it. Let's write it off and then please have we written the important. So now we have the probability, the truth one there. So we would so the two events are, let's call it as probability of U A and the probability of P. So we have these probabilities there. That the probability that a man is known to speak the truth and his probability is 2 out of 3. Whilst that the man also throws a die and reports that the number of things is 4. Sorry. So we are supposed to find the probability that the number obtained is actually 4. The number obtained is actually 4. So what are we looking for? Essentially, what we are looking for is that we are looking for the probability that, let me see if I've muted myself or not, because I remember I muted myself. I've not muted. Hey, look at what you are typing there. Sammy, and then look at Sammy with you, housefly. Look at what is Samuel? Please, this is what you are saying in my class. You do not have to do that. You do not have to do that. So we are looking at probability of T obtaining the 4. So that is from Okay, so hello. Sorry. I think you can hear me now. Sorry, sorry. So now here is the key thing. We have these probabilities there that one is probability of our good friend from the slides. I want to teach that according to the slides here. That he chose, he speak the truth. The probability that he's speaking the truth is 2 out of 3. And he chose a die and report that the number obtained is a 4. So we want to represent it with E. Probability that he really speak the truth. That it is 4. So the E represents obtaining 4. It is. The probability of obtaining 4. That is what the E represents. Probability of obtaining 4. So we know that when you throw a die, the probability that you obtain 4 from our elementary probabilities that we've learned, that will give us 1/6 because we are looking at 1 out of the 6. That means that the probability of you not getting 4, probability of you not getting 4, which is E1 complement, but the notation in the slide is E2. As we said, we subtract from 1, that gives us 5 out of 6. And that is obtained by subtracting this from 1. So you subtract this from 1. And that will give us 5 out of 6. So now we go to each of them. So we are now looking at the probability that the question says that probability that it is actually 4. So we want to look at it, he speaking the truth. The question says that the probability that he will speak the truth, and he will speak the truth, given that it is actually 4, is 2 out of 3. So that is granted to him. Oh, 2 out of 3. That means that he can choose not to speak the truth. Given that he had 1. And that is 1/3. As well as there is a possibility that he may actually speak the truth, that he did not get 1. Sorry, did not get E2. And for that one, E complement. That is what he is known for. We get it as 1/3. The probability of A complement. I think we won't be making use of this part. A complement. I don't think we're making use of this part. So let's not deal with this part. So let's look at the essential part. That is from the question. We will mainly focus on when we are trying to write the question that he is actually speaking the truth that he has had for. So actually, the probability that what he has obtained is actually for is probability of obtaining for, given that he is speaking the truth. And by extension of the Bayes theorem, we have probability of obtaining for times the probability of speaking the truth when you have for. All on the probability of getting for times the probability of speaking the truth, given that you have for, plus the probability of not getting for, and the probability of speaking the truth when you did not get for. So that is where we had it as 1/3. And that is hard gotten by subtracting this from 1. That will give you the 1/3. And then when you do the substitution, you have this as the answer. Please, I hope you understand.
Yes, sir.
Okay. So we have the trial as a trial work. We will look at it. And that brings us to the end of today's session. That brings us to the end of today's session. So we have effectively completed Unit 1. On Saturday, we will look at Unit 2. On Saturday, we will look at Unit 2. I will plead with that if we can bear with me. I heard that you are very good waking up at dawn. So I wanted to look at we meeting at 4 to 6 o'clock a.m. to have our Saturday meeting.
Yes, sir, we can do that.
We can do that. Oh, that's great. So let's have our meetings on Saturday 4 a.m. to 6 a.m. and then on Wednesdays 6 a.m. to 6 p.m. to 8 p.m. Okay, I think we've been
Agreed, sir. Agreed.
Daniel. Daniel has a
Sir,
concern.
you are too preoccupied.
Sɛ
Oh, but that's a
nkafoɔ no koraa deɛ
Yes,
yɛtumi de battery a I think sɛ nka ɛbɛboa.
what's up at 3? But you're in the 4.
Oh, that day, Thursday, munya.
Yɛabom abɛsi 6 na ɛno ano no 3 hours solid.
Wait, let's have it at 4 to 6. And then please you can kindly take off the recording of this session. So I think we are done. We'll have the meeting 4 a.m. to 6 a.m. and we have the Wednesday 6 p.m. to 8 p.m. Thank you very much. Please have a good evening. Bye.
Thank you, sir. God bless you. Good night.
Hey, Yahumo.
Mr. Boatin bɛsere saa. Hey.
Everyone